Okay, so 4, 4. So 4, 4 is proving triangles are congruent by side, 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 which is the first shortcut. Okay, it is a postulate, so it's called side, side, side postulate. The number 12 does not matter. It's just the 12th postulate in the book. Okay, but not important. So what is important is what it's called, side, side, side postulate, or SSS. If 3 sides of one triangle are congruent to 3 sides of another triangle, then the triangles are congruent. So in a situation like this, I need to know nothing about the angle measurements, okay? If I had 2 triangles like this where they're marked and each side has a corresponding congruent side in the other triangle, then these 2 triangles would be congruent. My congruent statement could be A, B, C, and then I got to pay attention to the order in which I wrote that. So AB is the first side, which has 1 tick mark, and then BC is the bottom side that has 3 tick marks, which means I have to go in the same order on the other triangle. 1 tick mark to 3 tick marks, which means I have to call that triangle DEF. So it was a little bit easier figuring out the order of the letters when we had marks on the angles. We don't have any marks on angles this time. So you've got to pay attention to the order of your letters. However you establish the first one is up to you, but when you go to write the second one, it has to be in the correct order. So you're going to see stuff like this, which is kind of like just a one-step proof. Decide whether the congruent statement is true and explain your reasoning. So you don't need to write a big statement and reasons 2-column proof, okay? But you do have to give backing to it. So this says DFG is congruent to HJK. So DFG goes 2 tick marks to 3 tick marks. And then the second one is HJK. 2 tick marks to 3 tick marks, and that third side is also matches congruent. So my answer would be what? Good. Yes, and the reason is side, side, side. If it was a proof, which it's not going to be because it's only one step, but if it was a proof, I would go through list my given, which is that DG is congruent to HK. DF is congruent to HJ, and KJ is congruent to GF. That's given to you from the picture. That would be step 1. Step 2 would be the triangles are congruent, and the reason would be side, side, side. Okay, same directions, different type of way of delivering the information. So now they're giving you the measures of the sides of the triangle. So AB says 3. Do you have a 3 in the other triangle? No, right away I know that those are not congruent, right? So my reason is no, and the 3 pairs of sides are not congruent. We have 2 7s, and that 9 is reflexive, so we would have 2 9s, but the fact that the 3 does not equal the 4 makes it so that these are not congruent. Okay, 3, same direction. Decide whether your congruent statement is true. Explain your reasoning. Is it true? Yes. Okay. QPT is 2 tick marks to 3 tick marks. RST is 2 tick marks to 3 tick marks, so the order of the letters match, and I have all 3 pairs of congruent sides. God bless you. So it says JKL has vertices J -3, -2, K 0, -2, and L -3, -8. RST is 10, 0, 10, -3, and 4, 0. Graph the triangles in the same coordinate plane and show that they are congruent. How do you show that they are congruent? What would you have to do once you graph these? Use the distance formula, unless they're horizontal or vertical, right? Use the distance formula to find the lengths of the sides and then show that each side in the first triangle matches a corresponding side in the second. All right, so the first thing I did was graph each of the points and label them so I know what I'm talking about when I find side lengths. And then I found the horizontal and the vertical side lengths because those you can just count. So I've got 2 3s, which means that's one pair of sides that match. I've got 2 6s, which is the second pair of sides that match. And the last thing I have to do is use the distance formula to find the remaining side. So K was 0, -2, and L is -3, -8. So I'm going to find the length of LK. We'll do 0 minus a -3, which becomes +3 squared, plus -2 minus a -8 becomes +8 squared, 3 squared, plus 6 squared, 9 plus 36, which is the square root of 45. So if it was asking me for the length of LK, I would show that the square root of 45 would get simplified. This would be 5 and 9, which is 3 and 3. So this would be 3 root 5. Okay, if I'm just using it to prove that the side lengths are the same, I don't need to simplify it. If it asks you for the length, then I'd expect it to see simplified. But if you're just showing that they're the same, you don't need to. Does that make sense? Because you're comparing them to be the same, which they are whether or not you simplify them. Okay, then the last side I've got to find is ST. So if S is 10, -3, and T is 4, 0, I would get 4 minus 10 squared plus 0 minus a -3, which becomes +3 squared, -6 squared plus 3 squared, 36 plus 9, which again is square root 45. So they told you at the beginning these were congruent. The work is what's proving it, okay? So the fact that if it had said, are they congruent, then you're answering yes or no, yes, side, side, side. They're telling you these are congruent, so the most important thing is to show the work, because the work is what proves that they're the same. So then I could say that SR equals JK, that's one pair of corresponding sides. I can say RT equals JL, that's the second pair of corresponding sides. And then ST equals LK. So side, side, side proves that these are congruent.
Are we going to use like a third line?
No, there's no such thing. Yeah, there's no such thing.
So even if like, so I mean, are they ever, with two lines, if they have the same 2 lines, is it ever going to be different?
Yeah, it could be depending on the angle between them. Right? If I spread those 2 lines out, that third side is no longer congruent. Does that make sense?
Yeah.
Okay. Yep.
When we're answering, like, if this is a question like this, and you have to put, like, all the segments are equal to each other, you have to put the little, like, segment thing on top of the letters.
No, I'm not going to be that picky. So if you do that, typically then you get the congruence. But if you put that or the equals, I'm not going to nitpick on if it's congruent or equals, as long as you can show that they're the same.
So to prove it, you have to write everything out. We can't just mark it on the graph.
So you have to show the work on the last one. And then if you did tick marks, that's fine, because then I'm assuming that you're showing that they're congruent. That's fine. Yep.
If we were writing it on a proof, like for SR equals JK.
Yep.
Would you put like, what would be like the reason? Would be like
God bless you.
counting?
No, so the counting got you the measure, which I would just say that that's given. The given would be the lengths of the sides. So JK being 3 would almost be given, okay? But when you say JK equals SR, that's the definition, or you would say it's congruent, definition of congruent segments. Because you're saying if they both have the same value, then they're congruent. You won't get a coordinate question in a proof. You'd get something that's labeled, or you have to figure out. All right, so this says, explain why the bench with the diagonal support is stable while the one without the support can collapse. So think about it. And explain just means give me in your own words, so it doesn't have to be perfect. But think about why that's true. Okay. So the gravity's going to push on it the same way, right? What's the difference? So what does that do? It adds the support. Pretend they're not. So pretend the players don't matter. It's the actual structure itself.
Since the bench on the right has nothing in the middle, it can collapse to the middle, while the other one has something in the middle.
okay? The one on the right could collapse. What's happening by adding that diagonal in if the two sides are the same and the two sides are the same? What have you just created? Two triangles. What's true about those two triangles? They're congruent, right? So if I have two triangles stacked on top of each other with exact measures, are those triangles going anywhere? No. If I just put these four legs together, what can happen here? They can wobble, right? They can shift to the side. So anything that's got that extra structural diagonal, which is basically taking your, in this case, rectangle, and cutting it into two congruent triangles that are stacked upon each other, okay, is adding structure support, which is going to make it more stable. Okay, so, I mean, it's again, the words explain are pretty, this is your loose interpretation of it. But by adding that diagonal, we have now created two congruent triangles which are stacked upon each other, which is going to make this structure more stable. All right, so for 5, we're going to get 2 more shortcuts. Okay, lots of acronyms in this chapter. One is side angle side, and one is hypotenuse leg. So in order to know these, you've got to know what the definition of an included side or included angle is. And an included side is the side between the two angles that you're given. So if it said, what's the side included between angle A and angle B, then it's side AB. Okay? The side that connects those two angles is considered to be the included side. And then the included angle is the angle where the two sides meet. So if you look at that diagram there, angle C is the included angle between side AC and side CB. All right, so if I asked you what's the included side between angle C and angle B, you'd tell me it's what? Side CB. If I asked you what's the included angle between side AC and side AB and side CB? Angle B. Okay, so we understand what included means, right? It's where they meet or what connects them if you're talking about the sides. So that leads into side angle side postulate. SAS is 2 pairs of corresponding sides and then their included angle. So it has to be the angle where the two congruent sides meet. And think about the order of the letters. It's SAS, side, and then another side, and the angle that's between them. So this is not any angle and any 2 pairs of sides. Okay, it has to be the included angle. If you have 2 pairs of congruent sides and the 1 pair of included angle is congruent, then the triangles are congruent. Are these 2 triangles congruent? What information is given to you? 2 pairs of sides, right? What else do you need? The included angle. What do we know about that included angle? They're congruent because they're vertical angles. Does that make sense? So you're going to start to look for things like vertical angles. You're going to look for reflexive sides. You're going to sometimes get given that the lines are parallel. So you're going to look for alternate interior and alternate exterior corresponding all of that. Okay, so the order of the letters is important, right? So if I said A, B, E, what would I have to call the other triangle? So AB came first, right? Which has 1 tick mark. What comes first on the other side? DB, good. DBC. So be careful. And your reasoning is just SAS. Well, for this one, you would have, if this was a proof, I would have stated the given, and then I would have stated that the angles are congruent because of vertical angles. And then I could have stated that the triangles are congruent. Okay, so refresher on parts of a right triangle, because if you don't know this, you can't move forward. Okay, in a right triangle, the side opposite the right angle is called the hypotenuse. Okay, this will be the longest side of a triangle. So opposite the right angle is the hypotenuse, and then the other two sides are called the legs. So the two sides that meet to form that right angle, the two perpendicular sides, are called legs of a right triangle. And you need to know this because the next one is hypotenuse leg. So if I have two, they have to be right triangles in order to have a hypotenuse, right? So the first thing they have to have is a right angle because they have to be right triangles. If I have two right triangles that both have the hypotenuse marked as congruent, and then one pair of the legs, I don't need both, I just need one pair, then I have hypotenuse leg. It's the only one with two letters, but technically there's a third qualification, which is that it has to be a right triangle. Hypotenuse leg tends to be the one people forget about, okay? When you're looking at a triangle, if there's a right angle, see if it's hypotenuse leg first. It doesn't mean it's always hypotenuse leg, okay? But if you see a right angle, odds are that it is. So always try that first. So if I had something, let's say, like this. Are these two triangles congruent? Yeah. So the right angle on the right would also be on the left, right? It's not marked, but if they're perpendicular, it forms two right angles, which means both of these triangles are right triangles. Both of the hypotenuses are marked as congruent. And then what other piece of information is happening on this diagram that's not shown?
The tick marks are the hypotenuse.
That's not shown. So what's there that you know that's not marked? The what legs? The bottom leg? Nope.
The one that cuts it in half,
Which is called what? Nope. It's congruent to itself, which is reflexive. Okay, so that side that is shared is your pair of congruent legs. Does that make sense? So these two are congruent. There is enough information in that little picture to show you that. And the reason would be hypotenuse leg. All right, so again, state which congruent method can be used to prove the triangles are congruent. If none, state NC. So on A, what piece of information is there that's not marked? This reflexive side. Is that enough to prove these triangles are congruent?
Yeah.
What's wrong with it?
It's not the included angle.
Good. Okay, that's angle side, which actually is not something because it spells a bad word. Not just because it spells a bad word, but also it doesn't work. Okay, so these would not be congruent. Yeah, A. Yeah, there we go. Okay, B should look familiar, right? What's true about this one that's not marked? The reflexive side, and if that's a right angle, then this is a right angle. Are these two congruent? Yes, my reason? Hypotenuse leg. C, what's there that's not marked already? The vertical angles. So this one is congruent to this one. Is that enough information? What's wrong here? This only has one tick mark and this has two. Are those two congruent? No. And it's the non-included angle, so it's double whammy, okay? B, what's marked, what's there that's not marked? The reflexive side, are these congruent? Yes, my reason? Side, angle, side. And E, I've got a right angle and a right angle, those would be congruent. I've got one arc, 2 and 2. Are these congruent? What's it called if they're congruent? Is there an angle? No. These are not congruent. So you think about an equilateral triangle. An equilateral triangle is also equiangular, right? Which would all be 60 degrees, right? Can you have a teeny tiny equiangular triangle and a big huge equiangular triangle? If these are all, let's say it's 3, 3, 3, that would make that equiangular and equilateral. And let's say these are 10, 10, 10. Okay, those are two equiangular triangles, right? All the angles inside would be 60, But are they congruent?
No.
No. That's why there's no AAA. Okay? So there, it's not enough information. You have to have at least a pair of sides, which we'll get to next section. Okay? But that, it is not based on the angles.
So some of these, why is it not congruent?
Because it's all the angles, not the sides. Yep. So there's no angle. Yep.
So if the hypotenuse was shaped on both of them, then it would be...
No, you'd still need a leg. You need the hypotenuse and a leg.
What about the third angle?
That just tells you all the angles are congruent. Still not enough to prove that those two triangles are congruent. Yep. So A is two pairs, of course, of congruent sides, but that angle is the non-included angle. So if I was to use side angle side, then these angles would have to be marked. The two angles where the sides meet. Does that make sense? Okay. Just wait, we're going to add some more into the mix, and it's just going to get more confusing. So the good news is that you're getting these now. There's only two more you're going to learn, okay? Which we'll probably do on Monday. Your test is next Thursday, so it's a week from tomorrow, okay? And by then you'll have all of them. The more practice you get with triangles, the better you're going to get, okay? So right now, you either have to know all three pairs of sides or all three pairs of angles are congruent, which odds are now you're not going to need all that information because we have all these, okay? But now you've got side, 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 side angle side, and hypotenuse leg. And then we're going to add to it a little bit next week. So this one says, is there enough information given to prove that the triangles are congruent? And if there is, state the postulate or theorem. So there's a bunch of triangles in this diagram. It's saying, are triangles ABE, which is here, ABE, is that triangle congruent to CBD? CBD. So what do we know about these triangles? What information is there? We've got two pairs of corresponding sides, right? This one, whoops, daisy. This one matches this one. And this one matches this one. So if I were to separate those out, A, B, E, B, C, D. This is marked congruent to this, and this is marked congruent to this. So I've got the two pairs of corresponding sides. And then what other piece of information is given to you, Nick? The angles at the top. So it's telling you that individually, this angle is congruent to this angle. Okay? But both triangles also include this angle in here. What's true about that angle? It's congruent to itself. It's going to be part of both triangles. If I take the same measure and add it onto both triangles, is the large angle going to be congruent to the large angle? Yeah. So if I needed to break that down, that goes by way of like angle addition postulate and then adding the reflexive angle in, okay? Which I probably won't make you do. But that does make the top angles congruent. Does that mean these triangles are congruent? Yes. How? Side angle side. So two pairs of sides and then the angle where they meet. Questions on that one? So the two sides are already given to you, right? The two pairs of sides, like this one matches this one and this one matches this one, right? So then, so if I look at this triangle, right, there's one here, right, this blue one, and then the other triangle is this red one, right? That's what we're trying to prove. So they both have this top angle marked as congruent. But that full angle is part of what's inside that. So I would need to show that this whole angle equaled this whole angle. So they both already have one part that's congruent, and then I'm taking the same measure and I'm adding it to both sides, which is going to keep it congruent. Does that make sense? So that's a reflexive angle that could get added to both sides of the equal sign to show that they're congruent. Okay, same question, different types of drawing. Is there enough information to prove that the triangles are congruent? If there is, state the postulate or theorem. So what? Well, it's first. So we're talking F, G, H, and H, J, K. Are these congruent? What is it called? Hypotenuse leg. They both have a right angle. They both have a pair of legs marked as congruent, and they both have the hypotenuse marked as congruent. Then the only other thing you had to check was the order of the letters. So FG was matching HJ, which was the one side that was not marked as congruent. And then GH matched JK, and GH is the 1 tick mark, JK is the 1 tick mark. Okay, this is the last one. It says state the third congruence you would need to prove the triangles are congruent by side angle side. So it's telling you that you have two pieces of information, okay, that's given to you. And in order to prove that these triangles are congruent with side angle side, you need one other piece of information. So if ST is congruent to YZ and RS is congruent to XY, what's the one other piece of information you would need in order to use side angle side? Alexis.
Angle Y and S.
Good. Angle S has to be congruent to angle Y. What if I had said to prove that they're congruent using side? Then what, Evan?
We need a line RT equals X.
Good. Everybody understand the difference? Yes? Okay, perfect. Any questions? What if I said hypotenuse leg? What if it's not drawn to scale?
You have to be the right triangle.
You would need the right angle. And where would that right angle have to be? Either R and X, right? Or
T and Z.
T and Z. Does that make sense? Because one of them has to be the hypotenuse. Does that make sense? Yeah, everybody sees that? Okay, good. All right, so